12 years on Linux, thousands of hours inside terminals, configuration files, package managers, and desktop environments across more distributions than I can accurately count from memory. And last month, I fell down a research rabbit hole that left me genuinely embarrassed about how many fundamental things about the platform I use every single day I had never actually known. Not obscure trivia, not irrelevant historical footnotes. Actual facts about how Linux works, where it came from, and what is happening inside your machine right now that I had simply never encountered or never bothered to verify despite being a daily Linux user for over a decade. These 17 facts changed how I think about Linux, and several of them will change how you use it starting today. Fact 1. Linux is technically just the kernel. When you say you use Linux, you are almost certainly wrong in a precise technical sense. Linux refers specifically to the kernel, the core component managing hardware communication and system resources. Everything else, the desktop environment, the applications, the package manager, the file system utilities, is GNU software and other components assembled around that kernel. The correct term for what most people call Linux is GNU/Linux, a distinction that Richard Stallman has been insisting on for decades, and that most of the community completely ignores, including people who have been using the platform for many years without ever questioning the terminology they use daily. Fact 2. Linus Torvalds created Linux in 1991 as a hobby project while he was a 21-year-old student in Finland. His original announcement on a Usenet newsgroup described it as just a hobby, nothing big and professional like GNU. That hobby now powers the majority of the world's servers, every Android device on the planet, all 500 of the world's fastest supercomputers without a single exception, and an increasing share of personal computers globally. The scale of what that hobby became is genuinely one of the most extraordinary and improbable outcomes in the entire history of technology, and it happened because one student decided to share his work publicly rather than keep it private. Fact 3. The Linux kernel contains over 30 million lines of code and receives contributions from thousands of developers representing hundreds of companies every single year without interruption. Microsoft, the company that famously called Linux a cancer in 2001 and spent years positioning it as a threat to its business model, is now consistently one of the top corporate contributors to the Linux kernel measured by commit volume. That specific reversal represents one of the most dramatic and most consequential shifts in corporate technology strategy that the industry has witnessed in recent memory, and its implications extend well beyond any single company. Fact 4. Your Linux system is running far more processes than you have ever deliberately started, and the number will surprise you. Open a terminal right now and type the command to list all running processes, and take the time to count them carefully. On a typical desktop Linux installation with a moderate number of applications installed, you will find between 150 and 300 processes running simultaneously at any given moment. The majority of these are system services, kernel threads, and background daemons that started automatically during the boot sequence and that manage everything from hardware communication to network connectivity to display rendering without ever requiring your direct involvement or even your awareness that they exist. Fact 5. The / at the beginning of every absolute file path in Linux is not just a separator character between directory names. It represents the root directory, the single origin point from which every file and every directory on every storage device attached to your system descends through a unified hierarchy. This design is fundamentally different from the Windows Drive letter architecture, where each storage device gets its own separate namespace. Understanding the Linux unified hierarchy properly changes how you think about where files actually live on your system, and how additional storage devices attach to the running system through the mounting process. Fact 6. When you delete a file in Linux, the file is not immediately and completely removed from your storage device. The system removes the directory entry that points to the file's underlying data blocks and decrements the link count associated with those blocks in the file system metadata. The actual data itself remains physically present on the storage medium until that specific space is needed for something new and gets overwritten with fresh data. This means that recently deleted files can frequently be recovered using specialized forensic and recovery tools if you act quickly enough before the storage blocks are reused and overwritten by incoming data from new files. Fact 7. Everything in Linux is a file, and this principle is implemented far more completely than most users ever realize, even after years of daily use. Your keyboard is represented as a file. Your mouse is a file. Your network interface is a file. Running. Processes are represented as readable files inside the proc virtual file system. Hardware devices appear as accessible files inside the dev directory. Detailed system information about current memory usage, CPU statistics, kernel parameters, and hardware state exists as readable and in some cases writable files distributed across the SICE and PROS virtual file systems. This design philosophy means that an enormous range of system information and direct system control is accessible through exactly the same file reading and writing operations you use for ordinary documents and text files. Fact 8. The superuser account in Linux is called root, and it possesses absolutely unrestricted access to every file, every running process, and every system function without exception or limitation of any kind. There are no confirmation dialogues, no warning prompts, and no safety nets of any description when operating as root. A single mistyped command executed with root privileges can permanently and completely destroy an entire system configuration in seconds, with no possibility of automatic recovery. This is precisely why modern Linux distributions strongly encourage using sudo to execute individual commands with elevated privileges only when specifically needed, rather than maintaining a persistent root session, and why experienced Linux administrators treat root access with extreme caution, regardless of how confident they feel about any particular operation they are about to perform. Fact 9. Linux file permissions are built on a 3-tier system covering the file owner, the group associated with the file, and all other users on the system. Each tier independently receives 3 permission bits controlling read access, write access, and execute access. When you see a permission string like rwxrxrx in a terminal directory listing, you are reading 9 individual binary flags that completely and precisely describe who can do what with that specific file. Understanding the system properly and being able to read it fluently gives you the ability to precisely control access to every file on your system in ways that remain transparent and predictable, rather than hidden behind graphical interfaces that obscure what is actually being configured. Fact 10. The Linux terminal is not one program, but a layered combination of distinct components working together in coordination. The terminal emulator provides the window, handles visual display, and manages keyboard input and output rendering. The shell, most commonly bash or zgesh on modern systems, interprets the command's U-type and manages program execution, variable substitution, pipeline construction, and scripting logic independently of the terminal emulator. The programs you actually run inside the shell are separate executables entirely distinct from the shell itself. Understanding that these are genuinely separate layers explains why you can change your shell without changing your terminal emulator, and why shell scripts written for bash run identically across different terminal emulator applications. Fact 11. Bash has a persistent history file that records every command you have ever typed in a terminal session across your entire time using Linux on that machine. On most systems, this history is stored in a hidden file called bash history located in your home directory, and it persists across every reboot indefinitely until it reaches a configured size limit and begins overwriting the oldest entries. If you have been using Linux for years, this single file contains a detailed and chronological record of your complete command line activity spanning the entire period. The majority of Linux users have never examined this file despite it existing, growing, and accumulating sensitive information throughout their entire Linux usage history. Fact 12. Linux distributions handle software installation through cryptographically signed package repositories, and the security model of this approach is fundamentally and meaningfully more trustworthy than the Windows model of downloading executable installers from individual websites of varying credibility and unknown safety. When you install software through your distribution's official package manager, you are installing software that has been reviewed, compiled by known build systems, cryptographically, signed and explicitly vouched for by your distribution's maintainers and security team. The same category of software downloaded as an executable from a random website carries none of those assurances and provides no verification mechanism. This architectural difference in how software reaches your machine is one of the genuine and seriously underappreciated security advantages of the Linux desktop model over Windows. Fact 13. The Linux kernel is monolithic in its architecture, meaning that device drivers, file system support, and core system services all run in the same privileged kernel memory space, rather than in isolated protected processes separated by memory boundaries. This specific design choice, which Linus Torvalds and computer science professor Andrew Tannenbaum debated publicly and acrimoniously on Usenet in 1992, in one of the most famous technical arguments in computing history, produces excellent runtime performance because kernel components can communicate directly without crossing protection boundaries that impose overhead. The trade-off is that a serious bug in a device driver can potentially affect the entire running kernel, rather than being contained within an isolated process. The debate about whether monolithic or microkernel architecture produces better real-world outcomes remains genuinely unresolved. Fact 14. You can install multiple desktop environments on the same Linux installation simultaneously and switch freely between them at the login screen without any conflict or instability. GNOME, KDE Plasma, XFCE, Cinnamon, and any other desktop environment you install, simply add their session options to the login screen selector. This means you can install KDE to evaluate it thoroughly without touching your existing genome setup. Compare their actual resource consumption and workflow characteristics on your real hardware with your real applications running, and make an informed preference decision based on direct extended experience rather than relying entirely on online recommendations from people using different hardware with different workflows than yours. Fact 15. The Linux kernel includes an automatic emergency mechanism called the out-of-memory killer that activates when your system exhausts all available physical memory and swaps space completely. When this critical condition occurs, the kernel automatically selects a running process to terminate forcibly using a scoring algorithm designed to free the maximum amount of memory while causing the minimum disruption to overall system. Stability. If you have ever experienced a Linux session where an application mysteriously disappeared during an intense workload without displaying any error message or crash dialog, the killer terminated it silently. Understanding this mechanism explains behavior that confuses and frustrates Linux users for years before they finally discover what actually happened. Fact 16. Linux supports copy on write semantics on modern file systems like BTRFs that fundamentally transforms how file copying and system snapshotting operate at the storage hardware level. When you copy a file on a copy on write file system, the system does not immediately duplicate the underlying data blocks on storage. Instead, it creates a new metadata reference pointing to the identical blocks as the original file. Only when one of the copies is subsequently modified does the system write new physical data blocks for the changed portions, while the unchanged portions continue sharing the original blocks. This mechanism means you can create complete bootable snapshots of your entire system state almost instantaneously, because the snapshot initially shares every storage block with the live system. Fact 17. The reason Linux boots faster than Windows on identical hardware is not primarily superior boot sequence optimization code. It is that Linux starts meaningfully fewer services during boot, initializes many of them, in parallel through the system init system rather than waiting for each to complete sequentially, and reaches a genuinely usable desktop state with substantially less background infrastructure running than Windows requires, before considering itself fully initialized and ready. The Linux system appearing at the desktop after 12 seconds is completely and genuinely ready for full use immediately. The Windows system appearing at the desktop after 45 seconds is frequently still completing background initialization processes for another 2 minutes before the system reaches equivalent actual readiness. Understanding this distinction fundamentally changes how you interpret and compare boot time measurements between the two platforms. 12 years of daily Linux use and 17 facts I either never knew or never properly understood, despite encountering the platform constantly throughout that entire period. The platform rewards genuine curiosity in a specific and satisfying way that no other operating system matches, because every aspect of how it works is visible, documented, and directly accessible to anyone willing to look carefully. Subscribe for ongoing coverage of the Linux details that matter for how you actually use the platform every single day.